This recording reviews factoring. We talked about factoring in a previous class. So this is just kind of review of what was previously discussed. So there are four main ways to factor. I call them the four factoring setups. I don't know if they're going to all be here in this lesson, but I'm going to see if I can at least find one of each kind. So the first one is when we have a plus plus, and I don't see that here in this worksheet. So whenever we have plus plus, meaning a trinomial that's like x squared plus something, when the trinomial is plus plus, your binomial when you factor will be two numbers that are both positive. And you're using consistently the multiply, add, multiply method, which is you multiply to the x squared, y squared, x squared, whatever, z squared, whatever it may be. So the variable is here, variable here. You're going to then add to this number, but multiply to the last number. So the last number basically determines if what we're going to be doing. So if it is a 10, you got to think of your factors of 10, what two numbers multiply to 10. And then you have to see which combination adds to whatever number is in the middle. Then we have minus plus. So same thing, add, multiply. Here though, however, we will have the binomials be minus minus. Because the only way to have a positive product and a negative sum would be if they both were negative. So like question number 3 down here is using that second technique. So I am multiplying to 24. So I think of all the factors of 24. And I ask myself, which one of these will add to 10? So it's add, multiply. So again, multiply to x squared is just x and x. So the only numbers here that when combined will give me a 10 would be the 4 and the 6. However, it'll be like -4 and -6 because we're multiplying to a positive but adding to a negative. So they both have to be negative. So thinking of it in this term sometimes can help you go through the factoring faster. Next setup is if it is plus minus. That is when you're going to have one positive and one negative, because the only way to have a negative product and a positive sum would be if one is negative and one is positive, where here the bigger number would be the positive value. So I just saw that. Here, number 1 shows just that. So multiply, add, multiply. So we're going to think of adding to multiplying to -6, but adding the positive 5. So think of all the combinations that we could have. And the only one when combined that gives me a positive 5 would be the first one, the -6 and the positive. Oh, sorry, the -1 and the positive 6. And like I said, the bigger number would be the positive to make this sum in the middle positive. So we choose choice 4. And I just realized that question number 7 does have plus plus. So let's take a look back at that one. So 2x squared plus 10x plus 12. So this has a GCF. So whenever you have a greatest common factor, it's an item that can be removed from all of them. So if I remove a 2, that means I divide each term by 2. And I'm left now at x squared plus 5x plus 6. And multiply. This is going to be plus plus. So x plus x plus. The 2's on the outside. And we kind of did the 6 over here, but instead of ignoring the negatives, we're adding to 5. So it'll be +2 and +3. So that's the first one. So now this question is, which one is not equivalent to this expression? So right away, I have the number 4 is equivalent to it. So it wouldn't be that one. If I distribute this, I get 2x plus 4 times x plus 3. So it can't be this one. If I was to instead distribute the 2 to the second parenthesis, that would give me 2x plus 6 times x plus 2. So I'm going to cross off that one. So the one that is left is choice 3. Choice 3 is not equivalent. If I was to factor this back, FOIL this back, I would not get 2x squared plus 10x plus 12. All right, so we talked about plus plus, minus plus, plus minus. The last one is it's when you have minus minus. So the only way to get minus minus would again be to have 1 plus 1 minus. But here now, the bigger one will be the minus sign, because we're talking about getting a negative product, but also a negative sum. To get a negative sum, the bigger number must be negative. So I don't see, oh, right down here. I know it's kind of cut off, but number 8 down here is a minus minus. So if I do remove a 4 here, I'm left with x squared minus what is it? 2x, obvious. No, sorry. X squared minus x, and then I'm taking the 120 and dividing by 4, and I get minus 30. And then I would add multiply. So x plus x minus. So I'm multiplying to 30. I'm just going to list all of them. I'm not going to worry about positive or negative right now. I'm just going to list them all out. But I want to add to -1. So the only way to get to -1 would be if the numbers were close together. So it'll be +5 and -6, because plus 5 plus -6 will give me -1, but 5 times -6 is -30. So that's how I would factor that one. I can't see the answer choices to know what the options would be, but that's how you factor. So I did one of each kind of the 4 factoring setups. All right, so I'm going to pause the recording at this point so I can switch documents and we can do some more factoring practice. Okay, so here's a new document. A lot of the same types of questions. Again, knowing the other setups would be extremely helpful. A question like number 1 here, I'm given one of the factors, and we have here only a binomial. So here we're going to be doing straight GCF. So if I know one of the factors is going to be 3x, I need to divide each term by that item to determine what the other factor could be. Because basically it's going to be 3x times, and we're looking for what's inside the parenthesis right now. So the 3's cancel out. Here I'm using my division rule for exponents, so we subtract our exponents. I'm left with an x. The x's cancel each other out, and 9 divided by 3 is 9. So we're looking for x minus 3. So a question like that, very easy. This is factoring setup number 4, factoring setup number 2. Here's factoring setup number 3. I don't see factoring setup number 1 here. Make sure that if it does say factor completely, you're looking for a GCF first. Okay? Greatest common factor means the biggest number or variable expression that can be removed from every single term. It can be a variable, it can be a number in a variable, it can be just a variable. And when you're solving with quadratics, usually you have to set them equal to 0, factor, and then solve for the variable. Each factor does get set equal to 0. That's including the GCF. So if there's a numerical GCF, you reject it. But if there's a variable GCF, you also have to set that equal to 0. The only other question I really want to go over here is to show you how like a part 2 or part 3 could be worded. And that's like we have here with 14 and 15. It just shows you how it would be and how we be presented for a part 2 or part 3 question. So I'm going to go straight to question 15 here. So again, factor completely. That's when, again, woo, 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 you should realize to yourself that it probably is going to be a GCF, and I am going to have to keep going. So here, my greatest common factor will be 5x. That's the item that I can take out from each term. So when I divide each term by the 5x, this gives me what's left over. So I'm going to put that inside the parenthesis. So again, cross off, use my exponent rules to subtract the exponents. Negative 20 divided by 5 is negative 4. X squared divided by x is x. This cancels out. Then I have 60 divided by 5 is 12. So minus 12. So this is a minus minus. So I know I can set up my double bubbles, my binomials. 1 plus, 1 minus. Now I'm thinking of 12. If it's easier to do the -1, +12, +1, -12, by all means do that. Or as you become more proficient in factoring, you can just look at the numbers and know if I have a negative at the end, I'm going to be subtracting. If I have a positive at the end, I'll be adding. So even though we still think of it as addition and multiplication, I'm technically going to be subtracting. And I know since it's minus minus, the bigger number is going to go with the negative sign. So to get a -4, I will have to have +2 and -6. And that's what you would have to do for that type of question. Again, that's like a part 2 question, very basic and to the point. I do have one more document I want to go over for factoring, so I'm going to pause the recording so I can switch the documents. Okay, here's our next document for factoring. So here we have difference of perfect squares, also known to many as difference of perfect squares. I've also heard some teachers call them difference of two squares, so they use the word dots. That is when you have a perfect square in the front, a perfect square in the back. It is a binomial, only separated by a subtraction sign. Again, hence the word difference of two squares, difference of perfect squares. Whenever you have these first things first, you want to ask yourself, is there something that I can factor out as a greatest common factor? If there isn't anything, go straight to doing your two binomials. And the setup of these is always the same. 1 plus, 1 minus. If I take the square root of the first term, that is what goes into the first slot of each binomial. If I take the square root of the second term, that is what goes into the second slot of each binomial. And that is how we get our answer of choice 3. Sometimes there'll be greatest common factors that have to be removed first, like question number 7. So now 18x squared minus 50, that is not, no perfect squares there. But if I remove a 2 from each, I now have 9x squared minus 25. So bring down the 2, set up our double bubble, 1 plus, 1 minus. Has to be 1 plus, 1 minus. So that no binomial squares. Take the square root of the first, that gives you your first term of each binomial. Take the square root of the second, that is the second term of each binomial. And there we have our answer of choice 3. These all kind of fall the same way. Something like number 9, you're going to have to remove the x first. And then you can factor like we were just doing. And we get choice 3. So we're going to always look for that greatest common factor first. A part 2, part 3 question could look like any that is seen here. I'm gonna do question 20, actually. I don't know if this is still in the algebra content, but I do like this question. So question like number 20, I have a fourth term that's still considered to be a perfect square. Square root of x to the fourth is x squared. Square root of 16 is 4. So now I have x to the fourth plus 4, x squared minus 4. Here's another DOPS expression, so I have to keep going. X squared plus 4 is not factorable. You cannot do sum of perfect squares. It does not exist. Square root of x is x. Square root of 4 is 2. So I get the entire final answer to be x squared plus 4 times x plus 2 times x minus 2. I've seen that pop up in the past. But there we have a quick review of factoring and all the different types of factoring that you would need to know for the exam. And that's the end of this little mini lesson.